I'm going to be speaking about heat, temperature, and thermal equilibrium. So I'm going to define what each of these are one by one. So let's start off with heat. So if I was to ask you what heat is, you would just say something that's hot or cold, or you couldn't give me a quantitative answer really. So in fact, technically heat is a type of energy. So you might be thinking why there's a billiards table, a snooker table, but I'll get to that in a second. So heat is a type of energy, and the diagram here I've shown you a billiards table, a snooker table. When I hit the white cue ball on the other ball, it's a type of energy, it's mechanical energy, whereas heat is a different type of energy. So if I give you a further example, so if I've got a mountain here, say, and I hold the stone up here, I'm just holding it, not letting it go yet. So at the top of the mountain, when I'm holding it here, there'll be energy, there'll be potential energy. And then when I let go, whilst it's moving, it'll have kinetic energy. And at the bottom, once it hits the bottom, what happens to the energy? Because we know through our physics classes and lectures that energy cannot be created or destroyed. So what happens to the energy? So that turns to heat. Not all of it, but so it turns to heat. And the units for heat is the joule. And that's the same as the units for potential energy, kinetic energy, and heat energy. And we represent heat by the letter Q. Heat. So let's have a closer look at what heat is. Let me give you another example. So if I said to you, there's a box and we put heat into a heat energy. So maybe you're thinking, how do we do that? So just an example, we leave it outside in the sun. And the sun heats the box up. Okay. So the sun's heating the box up. So it's heating up. What's actually happening? So if we look closely at each atom, the sun is actually causing these atoms to vibrate. So the more energy that comes from the sun, the more the atom vibrate, the hotter it gets. So the higher frequency, the more heat, the higher temperature. So if we reduce the vibration of the atoms, so we take out heat, so the temperatures will be cooler. So that's what heat is. Heat essentially is a type of energy. Units, joules, represented by the letter Q. So that's what heat is. Let's go to temperature. So now you know what heat is. Temperature is not that hard to define. So temperature is the quantitative measure of heat. So it's a way of measuring how hot the hotness or the coldness of an object. So for example, for a box A, and if I just give it a random number temperature, say 30 degrees. So that is how much heat it's got. So temperature is a quantitative way of defining how much heat a system's got. So I defined heat before, it's the vibration of the atoms, and the frequency and stuff like that. So temperature is just a quantity, it's a way of measuring it, how much heat a system's got. So temperature is a measurement of how much heat a system's got. Now finally, let's look at thermal equilibrium. The best way of me to describe thermal equilibrium is if I give you an example. So if I was to say, box A, there's a box and it's got a certain temperature, say 50 degrees. This is just an experiment. Like, just bear with me, you'll understand. So there's a box, it's got 50 degrees, and there's another box, box B, and that's 70 degrees. So if I was to put these two in contact with each other, they're touching each other, obviously heat would flow, but we must know that heat always flows from the hotter body to the cooler, that's the wrong way, from the hotter body to the cooler body. So it always flows one way, from the hotter body to the cooler body. So if I let's say I did this experiment, I got two boxes and I left it, so I came back later, and that's box A, box B, and I found that the temperature was 30 degrees for both of them. So thermal equilibrium would have taken place. So because the system here, they both are the same temperature. So let's recap that again. So I get two boxes, 50 degrees, 70 degrees. I put them together. Heat always flows from hotter to cooler. So if we leave for a long time, it'll be a matter of time till they both are the same temperature over here. And this process, this result, is called thermal equilibrium, where both systems are at equilibrium to each other, so they're both at the same temperature. So basically, thermal let me just give you the quick example before I end the video. So if I have a cup of coffee, and I don't know the temperature, say I don't know the temperature, so I put a thermometer in there to check the temperature. So basically, we don't know the temperature, so we put the thermometer in and we stir it for a reading. So what's actually happening is this is the thermometer system A, just say, like this is box A, and the coffee is like box B. So the two different systems, so we stir it until they get to the same temperature. The thermometer will get to the same temperature as the coffee will get the same temperature as the thermometer. So in fact, the coffee would lose some heat and the thermometer will gain heat, because it goes from the hot, like over here, hot to cooler. So until they're both at the same temperature, then we do a reading of the thermometer, say 1, 2, 3. So we read it off thermometer. So essentially, we're reading the temperature of the thermometer, but it gives us the right value because it's at the same temperature as the coffee, because we let it get to thermal equilibrium. So hopefully that was clear. Sorry if it was confusing. If you have any questions, let me know below, and hopefully I can help you clarify anything further. So yeah, that's all. So if I do a quick recap of what we did. So heat was how much type of an energy, how much a system's got, and the units for that is joules, represented by Q. Temperature is the quantitative value of the energy, and thermal equilibrium is when the systems are at equilibrium with each other. So thank you.